We are NeurAlbertaTech, and this is AlphaBlaster. I'm Tam, I'm the president of NeurAlbertaTech.
I'm Jen, I'm VP of Operations and Finance.
My name is Zachary Selk, I'm VP Technology at NeurAlbertaTech.
I'm Brandon, and I'm VP Technology for NeurAlbertaTech.
My name is Nicole, I am VP Communications of NeurAlbertaTech.
My name is Vidusha, and I am on the research team.
Well, I'm David, and I'm part of the research team.
Hey, I'm Cameron, and I am on the coding team.
Hey, I'm Ryan, and I'm also on the coding team.
AlphaBlaster is a tower defense game that we've designed that uses the player's level of attentiveness to change the status of the game. This game is an example of a BCI, or a brain-computer interface. What that is, in the simplest terms, is a way for you to control a computer interface or a game or something attached to that technology with the activity of your brain. So in this example, we're collecting EEG activity from the Muse, which is connected to the player's head, and that activity changes or modulates the game as time goes on. So when we take a look at EEG activity, there's lots of different frequencies that it could be coming in at. Usually the frequency band from around 8 to 12 hertz or so is labeled as the alpha wave band. That frequency range is usually representative of inattention. So generally speaking, when the power increases or the amplitude of that frequency bandwidth increases, inattention increases. So that means that the player or the person that's currently being recorded is paying less attention or less focused on the task at hand. And as alpha power decreases, that usually shows that the attention is increasing. That's what we're using to define attention and inattention in this game, AlphaBlaster. How long did it take for us to develop our project team? Well, we started out with just a few people who were really interested in taking leadership of this initiative. That was about 5 or 6 of us in a room that are now the executive team members. And we were able to establish a project team within about a week or so. That project team consisted of people who are interested in coding and developing the game side of things, as well as the neurotech aspect of it. Collecting live streaming data and pre-processing it, filtering it, and then adapting that to advanced movements in the game and the project itself. And we also had people who are on the research team that are working on answering questions, looking at how previous people have done this type of research or this type of project, and just trying to adapt and collaborate as the work goes on. After we've done that and we've established the groundwork, we're doing even better every day.
Once the Muse is set up on the user's head and the impedance has been checked, the Muse collects a bit of a baseline. So for the first 10 to 13 seconds of the program running, the user is just told to focus.
Right now we are streaming the data from the Muse using Muse LSL, which is a Python library, into a MacBook.
Then the EEG data is passed through a bandpass filter. So that's going to take out all of the data that's below 8 hertz or above 12 hertz. The baseline is collected and we've compared the current information to it. We then use the current information and plug that into a 3-second buffer. That 3-second buffer is collected continuously in order to compare the current activity of the user's brain to the previous activity so that we can actually figure out if they're attending to the game or not.
We add data to the buffer and average it amongst the 3 seconds to attempt to alleviate some of the noise that can be caused by blinking and other muscle movements.
For us to be able to pick out and pull out the alpha wave bandwidth from the data that we're collecting, we apply a simple Fourier transform of the incoming data. What that means is we try to pick out the simple sinusoidal waves of each frequency band, so let's say at 8 hertz, 10 hertz, 12 hertz, and things in between, and try to pick out specifically what's coming in from that stream. And then we apply a fast Fourier transform on the fly to pick out exactly the amplitude of each of those frequencies, and then we can use that to feed into the buffer, which lets the game know what has previously occurred and then gets updated as the game goes on to change the attention states of the player in the game.
We're just doing a simple Boolean state where either the player is shooting or is not, depending on whether or not the player's attention is above a certain threshold. Some of the things that the player has to take into consideration while playing is the fact that there's a limited number of bullets. So if the player is continuously attending to the game, then they'll run out of bullets and then lose. But also if they are not attentive, then they'll just be overrun and then lose as well. So they have to create a balance of choosing when to be attentive and when not to be, which is an interesting and difficult task.
Now, discussing the future directions of this project can be kind of interesting because even though at this point in time it's a pretty simple project with a simple scope, we can use it as a foundation and a building block for more complicated and more interactive games for all kinds of populations. One big example is children with ADHD. Things like this have been done before with very restricted and very limited EEG applications where the children have to be in a lab setting and confined to it. This allows more easily accessible instructions and more easily accessible materials for people to do this at home in different settings and things like that. It also allows us to create a more complicated game in the future that has more dynamic parts, more movement or more changes so that they can learn how to modulate their attention and change that in different settings as opposed to just looking at a screen dead on.
Right now, my biggest challenge has been, thus far, just the time constraint that we've been on and trying to get everything organized and set up and done in such a short period of time. So we had to make sure that we were trying to do something that was feasible in 2 months. So that's why we decided to make a simple 2D game that has one input, is based on alpha, which is a relatively simple concept in neuroscience. Box, which is a Python library that's used for a lot of EEG data processing and collection. We ran into problems using it because its main focus is on doing pre-processing on data that has been collected and stored in a file with certain encodings previously, and what we need to do is on-the-fly processing. So we had challenges figuring out how to use that effectively.
In general, we had issues connecting the Muse to different computers and getting code to run on different sort of computers to connect with the Muse and use the Muse data.
It's really difficult to try to collect and assemble a group in such a short time span because we had about 2.5 months to go from creating the group entirely to submitting our final project, and as you can probably guess, there's lots of things that can go wrong in between that process, between recruiting people, but also just working on tech and working on the production of the project.
Another one of the challenges that I faced personally but also affected the team was that I had to go to Ontario for 3 weeks for training for a service dog. I now have this wonderful boy with me. His name is Archer. He's improved my life significantly, but I know that it was really difficult for the team to have a core member of the exec team, of the project team away for such a long time. I had to do a lot of catching up when I was back, so that was just another thing that was thrown into the mix of challenges that we faced, but in the end it was all worth it.
Most shocking part of this entire experience, and the thing that I'm most proud of from this, is the fact that we learned about NeuroTechX and the student club competition in early February, and that's when we started things up. We didn't think we would have been capable of submitting something within the 2-month time span. We thought we would just be spectating for the time being and then building something up for the future, but we were able to not only assemble a team, but actually get work done together and have something done. And to that, I have to say that I'm extremely proud. I'm in shock of the amount of work that people were able to put in, and just the adaptation and fixing the problems that came up. All kinds of adversities arose with this process. Things from little problems like fixing the background color and changing that took us 3 weeks to get through. Very simple challenges in the project could seem like daunting tasks when you're going through them. And now that we have all of these things out of the way, it's fascinating to look back and realize that in basically 8 weeks, we were able to take just a novel concept and an idea of some kind of game controlled by alpha waves to the project that we're submitting today. It's a very exciting development, and I can't wait to see what we can do in the future with a lot more time.